All right. Hello, everyone. Let you all trickle in here. If you found yourself here today, you are at blower door 201 from Retrotec. I'm going to let all of these Zoom pop-ups go ahead and get out of the way so we can get going. All right. Looks like quite a few of you showed up today. So this is probably one of the most requested webinars that we've had is just, once you get your blower door reading, what's next? How do I actually identify where the leaks are, where the comfort problems are, and then move forward? So in this webinar, I'm going to show you a few different ways where you can do that. Pretty much all of them requires your blower door, plus some additional tools to make those air leaks visible. I mean, that's one of the hardest things about what we do is we're chasing down something invisible. So any way that we can make those air currents that are going through those air leaks, any way we can make those visible is going to make our job a whole lot easier. So let's go ahead and move forward here. So we'll dive right in. One of my favorite ways to do this is with smoke testing. And there's some different machines that you can use with your blower door to be able to see what's happening through the envelope. The two that we carry and that I like to use are the air tracer, which is still fairly new. One that we've had for a long time was the Tiny S smoker. This kind of replaced that. We still carry both, but the air tracer is much more affordable than the Tiny S was, and does the same thing. It actually heats up faster, gives you smoke immediately, tells you how much you have left, and it doesn't leak. So that's what we really like about that. And basically, that small handheld fogger is really good just for identifying where the air leak is. Right, you're not going to fill up a duct system with it. You're not going to fill up a room with it, but you can see how air is interacting with a surface if you have a pressure behind it. So I'll show you a few different ways of how I use it. The other one is this larger smoker. This one you actually can fill up an attic with or room with. This one's called the Power Tiny. We've had it for quite some time, but this one's battery powered. So you don't have to have a big extension cord to haul around with you if you're going around different spots in the house. I like to use this one for new construction where you can really fill up a space or you can direct it in certain areas. If you're pressurizing the house with your blower door, that way, if you have somebody that you're working with that can be on the outside of the assembly, then that way you can see where that fog is escaping from. So I've got some examples of how that works too. But this is also great for really seeing where all the failures are in a spray foamed attic. So if they encapsulated an attic with spray foam, you can really fill it up, put pressure behind it with your blower door, have somebody outside that can really see where it's failing. A lot of times it's the soffit. That's what we see a lot, but it can fail in other places too. So this is a quick clip. This is actually a commercial building that we tested a while back. This is the Tiny S. So, with this, we didn't need like a whole bunch of fog, right? I mean, you can pretty much see what's going on there. The air barrier here is supposed to be the roof. Clearly, they missed a spot. So we got air coming in through penetration to the drywall that's not supposed to be there. So even though we really couldn't get in there and look around, we can see that there's a problem. In this case, we just reported it to the GC of what we found, and then they know how they put it together. They know where those connections are of those dissimilar materials, so they could easily go in there and find it. So that's just a quick and easy way to prove that it's there. So this was a large dormitory building, so I think we had about 14 fans set up downstairs to be able to give us that pressure. So you can run your blower door in either direction. Here we depressurize, but you can also pressurize and watch that fog go into the leak. But that's one way you can use a handheld fogger. This one kind of shows an example of both. This is my buddy John Esquivel down in Austin, Texas. This is a handheld fogger that's being used to kind of track down where some humidity problems were happening in a house. So behind this door, there's an attic access. So you can see he's going to use a couple of different ways to see, how this attic space is interacting with the blower door. So that attic has been encapsulated with spray foam. So it really shouldn't be pushing that much fog into the rooms. And we're pressurizing. So as we pressurize and push that smoke, it's going to go towards the leaks. He also did some zonal pressure diagnostics. We'll talk about that in a minute. But then to really prove, like, okay, like we can see that it's leaky, but let's really dial it in and see where those leaks are occurring. So Here he's using that big power tiny. There's a hose you can get for it, so that's what he's using here. So you can kind of direct it where you want it to go. So he spent quite a few minutes up in the attic, just making sure he's got a good coverage of fog kind of throughout that attic. And just make sure he filled it up just enough so that he can run his blower door and not run out. But here's some footage from the outside. So this is what I was talking about before. So those soffits got missed. And that's one of the hardest places to get to if you're going to encapsulate an attic. If you're just getting to it from the outside, you can see there's quite a bit of detail along the bottom of that soffit. So like just dropping those isn't really that easy. In a lot of cases, that's what you have to do to really get to it. You got to drop that soffit board and then give yourself something to spray against right there on the edge. If not, you got to set yourself something up from the inside. But yeah, here you can see it definitely got missed. So even though this attic got spray foamed, it was still having a lot of humidity problems afterwards because it was still super leaky at the end of the day. So that's what they missed. So you can use fog in a couple of other places too. This is with the air tracer handheld fogger. The blower door is not running here. It's just the HVAC system, and we've got a high res manometer reading that room too. So that room has got a pretty high positive pressure on it. So you can see that over pressurization is pushing air out underneath that door undercut. We can see that with the fog, and we can see that with the number on the manometer. So it's got some pressure balancing issues. There's a lot of air that's being delivered to that room that can't get back to the blower. So if it's blowing out underneath that door undercut, it's blowing out to the outdoors somewhere too, where there's leaks to the outside. So same room, but we're going to use the blower door to pressurize the house. And so we can see that fog quickly escaping into that room. So this room's got a lot of stuff going on here. It's over pressurized, but it's also leaky. So this is kind of a double whammy here. So even though it is super leaky, it can still overpressurize. And so that means since that fog is going in there, it's eventually going to make its way outside. And so that's what's happening with that supply air that's being delivered to it. As it gets delivered, it just gets pushed outside. Whatever doesn't come back through that door undercut or any other interstitial leakage, it just gets pushed out. So that's just a lot of our conditioned air that we're just actively driving to the outdoors. So so we can see that with just the HVAC system running, and then we can see that there's also a lot of air leaks for that conditioned air to escape with the blower door and the fogger. So that's one of my favorite ways to use that handheld fogger is to pressurize the house and then to just shut doors. Whether if I'm talking about a residential building or a commercial building, for commercial tests, we do this a lot in hotels and hospitals, schools. Lots of times you'll have rooms along an exterior wall. So just start shutting doors and get your pressure up and see if you have fog that's being pushed up underneath. That's a way that you can see if that room needs to have more attention paid to it to see where those leaks are to the outside. So it's just a quick and easy way to check if there's a problem or not. Here we can see that there's a couple. And back to the big fogger again. This is, as you can see, it's a new construction job. They were trying to get this house to about passive house level of air tightness. So zero point 0.6 air changes per hour at 50 pascals. So we're pushing on it. We're about positive 50 pascals here. That pipe that you see, oh, let's see, let's back up here. That white pipe, that PVC pipe, that is actually a gutter. So this house has interior gutters. The owners wanted to have gutters, but they did not want them to be exposed from the outside because they thought they would maybe take it away from the aesthetics of it. So the gutters go from the outside and then drain into the inside back to the outside. So pretty there's a lot of details there that you have to pay attention to make that work. And what we learned from doing this, well, let's go back. What we learned from doing this is that they missed a lot of those penetrations where that gutter went into the envelope. So here you can see that fog getting pushed right out where that gutter goes into the house. So now he can see where it's coming from. He can trace it down, get up under there and actively seal it as we're finding it. So yeah, so that's one of the reasons why they miss it because it was just like way up under a soffit. But it's a good thing that we did that before they put up those soffit boards underneath, or else they'd have to pull them back down to really get to it. So that's some blower door assisted air sealing to use fog, the blower door at the same time, have somebody else outside to be able to spot it, see where it's coming out, and then do something about it. So there was quite a few of those that hit up. So that one got missed. So did the rest. So whether if it's an existing building or new construction, doing some checks with fog with the blower door can help you a whole lot. And this is one of the approaches too that I think any insulation contractor should be doing, especially if you're a foam contractor and you're using a spray foam to encapsulate anything, whether if it's a crawl space or an attic. No foam job has got to be perfect. A lot of them are far from it. I've tested way more bad foam jobs than I've tested good. So they really should be checked. Do a before blower test, blower door test, and after, and then fog it and see what you missed. And then go back behind and patch up those spots that got missed because something pretty much always gets missed. So you really shouldn't just code it and hope for the best. I mean, there's a way that you can measure it and then track down where the failures are and then fix it before you turn it over to the homeowner. So that really should be a standard process for everybody that's doing that. So that's smoke testing and just some of the different ways that you can do it, some different tools that you can use, some different approaches that you can take for different types of building, different types of buildings, sometimes at different times throughout the building process. So it's just an easy way that you can just make that air visible. And the good thing about smoke testing too is you can use it pretty much throughout the year. We'll get into thermal imaging later, that you kind of have to plan around the weather. We'll talk about that in a bit, but smoke testing is, if you plan to do thermal imaging or zonal pressure diagnostics, then I usually like to keep some fog with me too, just in case I want to make those two agree with each other, just to kind of for a sanity check. It's nice to do sometimes. We'll jump into zonal pressure diagnostics, and then we'll stop and take some questions. So this is a process that's been around for quite a while. This comes from the weatherization industry. So weatherization is, the folks who are usually working with government programs, working with affordable housing programs to identify where existing homes are failing, doing before and after test in, test out, blower door tests, and then coming up with a plan for remediation. These are your energy auditors that are doing that are working with government funding, weatherization assistance programs to do this. So we have contractors all across the country who do this. And so this type of check, zonal pressure diagnostics, is used to really see how the living space is interacting with an attic or a crawl space or basement. I mean, those are really the zones that we're looking at. And this is really how this should be applied. You shouldn't be checking bedrooms like this because there's just so much interstitial leakage back from that bedroom to the conditioned space. This really just works for those zones that we're not living in. So garages, attics, and in crawl spaces. So this little chart right here is handy. This was kind of put together as this process came about. And so what we're doing is we're running our blower door to negative 50 pascals, just like we would to run a blower door test to get our ACH 50 or our CFM 50 number. And then we're using a second high resolution manometer. So our solo manometer is perfect for this. And so what I'm doing here is I'm checking a vented attic in the picture that you see to the right. And that thing going in through where I'm actually accessing it through a leak I found between the bath fan, metal housing, and the sheetrock. That's our multi probe that we use. It's got a little yellow magnetic adapter. You can also use that probe as a static pressure probe as well. But you can use it for a variety of things. You can balance ERVs with it if it has test ports built in from the manufacturer. But you can also just get into all kinds of nooks and crannies in the building envelope too. So this is great for accessing areas where you're trying to do zonal pressure diagnostics. And so let's talk about what these numbers mean. So this attic, you can see on this chart here that I highlighted, we're getting 38 pascals. And so that's with the house getting to negative 50. So we're seeing that pressure difference there. So if we look at this chart, what a zonal pressure diagnostic reading is, it doesn't tell you like the percent leakage to the outside. What it tells you is a ratio between the leakage between that zone to the outside and that zone back to the inside. So what that means here, with it being 38, if we go over, that's pretty close to 37. So that's the zone to the house. So that means there's a 13 Pascal difference between that zone and the outside. And so what that means here, if we look at it, about half as much air is leaking from the zone to the house as from the zone to the outside. So there's some leakage between that zone to the house. That's a vented attic. We really want that to be completely outside. And here, what we're seeing is, it's not. There's a lot of interaction there between that vented attic and the house, which we don't want. If we were in a cold climate, that would be a big driver for ice dams. But this house is in a warmer climate, so this it wouldn't see that. What these implications really mean a lot of times has to do with where you live. But in this case, in the summertime, when we get that reverse stack effect, we're just pulling in 140-degree attic air a lot of the times. And so we're making our HVAC system work way harder than it would have to otherwise if we had an airtight ceiling plane. So this is just a way that we can spot check that. If I'm working with a homeowner, I'll use this for my own reasons to kind of see how certain areas are behaving. Maybe I want to see how well a vented attic is really vented, or maybe to see if there's some connectivity between the house and the vented attic, or if it's a spray foamed attic, to see how good of a job they actually did. That's kind of what John Esquivel was doing in that video before when you saw the DM32. Kind of got a similar number as this here. I wouldn't dare explain this to a homeowner of what I'm doing. I mean, the whole idea of a blower door to a homeowner too is just already kind of like getting close to being over their head. If we get into this kind of thing, I would just say like, look, this is just a pressure check to kind of help me figure out how severe the problem is. But having this chart is really handy to go by to really show you what the numbers mean. But one of the most common misconceptions about this is that, oh, like I see that that number means it's a certain percentage leakage, and it's not. It's a ratio. And so having that chart to refer to really helps you. A lot of people have this memorized. I don't. So I always kind of need it to refer to just to make sure that I'm actually interpreting that result correctly. So we'll dive into some scenarios here of what this means. So if you have your blower door running, here you can see it kind of in the center of the house. If we just have our manometer, it'll read 0, right? Because we're not referencing anything yet. So if we just turn our manometer on and we don't have it connected to anything, it should just be reading 0. It's not going to read a number until you reference it to some other place. So if we use this example here, where we connect our manometer to the attic and we read 20 pascals, and that's a vented attic, or really of any kind of attic. If you read that, it's not great. But in this case, it's a vented attic. That's not a great number. We want vented attics to be outside. We want them to have plenty of ventilation. We want them to have good soffit ventilation and good top ventilation, whether if it's a ridge vent or a gable end vent. So we want them to kind of be isolated from the living space, have a good airtight ceiling, and then pull its air from the soffit and then up through the top. If you get a reading like this, it means it's kind of like half and half. It's kind of like half vented, half encapsulated. It's not vented very well, or there's some connectivity back to the house. It's just not going to perform well. And this is how we get a lot of really high humidity problems in vented attics. This is where we see a lot of condensation happen on ductwork, on air handler cabinets. Sorry, this thing's wanting to go ahead of me, and things like that. So we want to be able to get that air in through the soffit and out, and not really get any air mixes from the attic to the house. But in a number like this, you would see a lot of things going wrong. And so that's what we want to avoid. We want vented attics to be outside. That's it. And if it's an encapsulated attic, we want to make sure that's inside with as little leaks as possible. So if we jump ahead to that example, if we see a number kind of like this, if we reference the attic and it's encapsulated along the roof deck and we're really not seeing much of a difference, then that means they likely did a good job sealing it. So yeah, I would be happy with that. You can do this with crawl spaces too. If you have an encapsulated crawl space, you can kind of do this check to see how well they did to seal that up. As long as you can get that probe in there somewhere. A lot of times this is where it is really handy to use that multi-probe that we make. So if you can get in between like a supply boot or return or wherever to get in to reference that crawl space, that's great. If you have to run a tube from the outside, just make sure that tube's really not in the sun. But sometimes that's just kind of how you have to do it. So just be mindful of that. Just keeping your tubing on a shaded side is going to help you with that, because you don't want that tubing to heat up. But if you can connect it from the inside somewhere, that's great, because if you use the multi-probe, it's got a 1/16 of an inch tip. So usually you can find somewhere that you can get in there and access that to get a good clean reading. But the same rules apply. If you get something like 20 pascals, there's a lot going on there that that we want to fix. Maybe we want to seal that up a little bit better. Plus, two, you can just use your second manometer as a way to just kind of probe different assemblies. So here, this is the same house that was having high energy bills. They were having high humidity problems in the summer and the shoulder seasons. I took these pictures before the Solo came out. The Solo manometer would actually be perfect for this. That way you don't have to use a whole other expensive dual channel manometer. But yeah, you could use that if you wanted to and just reference one of the channels. But yeah, the Solo is just kind of the perfect sidekick to have for something like this. So let's start with this picture on the left. What I'm doing is I'm taking that probe and I'm just kind of wedged it in there to get up underneath that baseboard between the carpet. So now I'm kind of reading some activity inside that wall cavity. And so I'm getting quite a bit there. I'm reading about positive 22, and the blower door is running to negative 50. So if I'm reading that high of a pressure, that means I've got quite a bit of air leaking into that wall cavity from somewhere. That's a high number to read. I usually want to see that number a lot lower if I'm going to determine if it's airtight or not, or airtight enough. But if it's keying into the 20s, that's significant. And so what we found is that this wall actually goes up, and then as it extends, it actually turns into an attic knee wall that was open to the attic. So as we were running the blower door to depressurize the house, it was just pulling in attic air into that wall. And so that happens in the summer too. So when we're cooling and it's hot outside, we get that reverse stack effect. That's just going to pull air in down from the top and then lose it out from the bottom. Air travels from the path of least resistance, not much resistance there at all, with just the top of a wall open to an attic. So we ended up blocking that off and foaming it to get it good and sealed. This picture here on the right is an interesting one. You can see these steps have had some problems. Interior staircase here, where they've kind of gone in and cocked it a few times after it's separated the tread from the riser. I didn't have to make that hole. It went ahead and separated again after another kind of wet season that we had. And I was able to get that probe kind of way in there. And I was running the blower door. You can see we were getting a pretty high number again. We're getting close to 20 there. We shouldn't really be seeing that. The staircase is not on an exterior wall. It's kind of in the center of the house. But what we found is when we get to the top of the steps, after getting into the attic and taking a look, the floor joists, when you get up to the top, they ran perpendicular to the steps. And so there was an air pathway going from the attic into the staircase. So the fix there was to go onto that attic side where that floor joist opened up and just put in blocking and seal it. And we could get there. There was an attic knee wall that we actually sealed up as well. Attic knee walls are almost never done right. They really need to be well insulated and have some kind of rigid backing to go all the way down to seal to the ceiling below. A lot of people just seal them, to the bottom of the wall, but that spot in between floors is where a lot of the problems occur. So you want to make sure you get it all the way down. And so here, that's where that problem was occurring. It was occurring between floors, where those floor joists just opened up into the attic. So it was just getting into that staircase and causing that wood to get wet and then dry and then expand and then separate. So that's how we fixed that there. So now after we did that, it stopped. We could actually fix it and it would stay fixed. Noah, do we have any questions before we jump into this one?
Oh yeah, we've got a lot of good
I
ones.
figured we would. Yeah.
Yeah, a lot more than 101. So there's been some good ones. We'll go back to the smoke testing, and what pressure would you recommend smoke testing at?
Yeah, that's a good question. It depends. Just, that's the answer to every building science question, right? So if I'm just doing, if I kind of go back to what I was doing with the at new construction, if I'm just like really filling up the space, or even if I'm looking at an encapsulated attic, I'm fine with just letting that fan ramp up. I mean, you can turn it up higher than 50 pascals to really get some force behind it to push that smoke so you can see. I'm cool with that in that scenario. However, if I'm trying to look at leakage through a ceiling into a vented attic, low and slow is the way to go, because if you're in that vented attic where it's dark and you start filling that attic up with smoke, now you can't really see where it came from. So I think a lot of the times is just it's good maybe you to use something like this depressurize if you're in from the attic and just check some top plates. If it gets sucked in, if that top plate is leaking, then they probably all are. So it just depends on what your application is and where you are. Same for crawl spaces. If you're trying to look and see if you've got connection from a living space down into a crawl space, low and slow is good. When you start to see it kind of trickle in, head over there, take a look, and see if you can find where the penetration is, where it's failing. Otherwise, for these, usually you can just kind of you're just going to be doing light little puffs there just to really see what direction it's going, and just kind of follow it to see where the source is. Yeah,
Yep,
that's
it
it depends
depends.
on where you are, how you're using it. So if you're in a
Awesome.
dark, cramped space, just don't overload it.
Another one, we had a couple people remind us that if you're doing smoke testing with like a lot of fog, to
Yeah, call
remind
the
the
fire department.
neighbors and the fire department. Yep.
Yeah, that happens
Um, yeah, notify them. And then and we will be recording this and it will be available on YouTube later.
for sure.
Then let's see, we've got a couple more I know. Where did we get where is the table from, the pressure diagnostic table? And do you know where people can print that, get a copy of their own? I
Yeah,
it's
do we have
by
that in one of our manuals?
I don't think it's in any of our documentation. It's by Michael Blasnick and Fitzgerald, who were
Mhm.
weatherization pros in the 90s, but I
I
don't
know one
know.
place where you can get it from is if you go to HVAC school, it's HVACR school. If you look it up, that's Brian Orr's HVAC School podcast, but that's their website. There's also some really great articles in there. My friend Jenry Garcia wrote 3 articles on the proper way to practice and interpret zonal pressure diagnostics, and I know that chart is in there. So I should have put that in the slides actually. But yeah, check that out. Go to HVAC School's website and look up articles by Jenry Garcia for zonal pressure diagnostics. There's 3 of them. They're all really good. And yeah, it's in one of those for sure.
Yeah, that I think that would be kind of the answer to one that just came in of can we review how to use that ratio table again? I think Jenry kind of explains that really well in his videos.
Yeah.
Um, Question about the hoses. Is there a way to stop them from breaking down and getting sticky, or is there a better hose? So there was if the hoses are in a bag for a very, very long time, like a plastic bag, and trap the off gases in them, they can get kind of sticky. So not storing them for a very long time on their own, kind of using them a little bit helps. And then the newer tubes, I believe, are just more durable. And yeah, I think I'll be able to answer most of these. Let me double check. Then one question came in, can you use the DM32X for zonal pressure? Yes, the DM32X can be used. The Solo is just a more affordable alternative when you want a second gauge so that 32X can still control the fan.
Yeah, the Solo and the 32X have the same pressure sensor. They have the same auto zeroing pressure switch. So they behave and read pressure the exact same way. With the 32X, you get 2 channels, some graphing capabilities, and you can run calibrated fans with it. But yeah, the Solo is just really there just to read pressure.
Yeah, so I'll clean up the question and answer queue a little bit and we'll get to some more after this section.
Cool. Thanks, Noah. Let's see. We'll talk about pressure pans a little bit too, because this is another good way to be able to, see if certain spots are leaky or not with your blower door. I really need to go in and change the settings on my PowerPoint so it doesn't auto advance, but I didn't do that. So I'll be fighting it the best I can throughout the rest of this. So this is just a quick little recap just on what we're dealing with when we run a blower door to depressurize a house to negative 50 pascals. So we have our blower door set up. We're depressurizing, so we're exhausting air from the house to the outdoors. So, outside, let's just assume it's just a calm day. It'd be around 0 pascals of pressure. Inside of the house is negative 50 when referencing outside. But along the very skin of the building, right there on the outside of the air barrier, is positive 50. Um, Wherever the air barrier is, the ceiling, the roof, it's going to be positive 50 right along that edge. If you're doing some probing, like I talked about earlier with another manometer, or if you're using a pressure pan, you're going to be reading a positive number because that's air coming into the building. So this is what a pressure pan looks like if you've never seen one. It's a pretty simple device. It's just a plastic. pan with weather stripping around the edge, with a port where you can plug in a tube, just like on your manometer or on a fan. And then there's also a spot to screw it into an extension pole, like a painter would use. That way you can kind of reach up into high ceilings and stuff like that. We make them in a couple of different sizes. This is our smaller one to kind of go over can lights, supply vents, things like that. We also make a larger one that's 24 by 24 inches to get over bigger penetrations like returns and things like that. So you can actually spot duct leakage with these two. That's how you would do this. So this is also a really great application for the Solo. I just need to update my slides to get some graphics in there with it. But you're going to use your blue port and then connect that to the pressure pan. Our pressure pans are color coded just like everything else that we make. So there's a little blue port on it to remind you of where to hook it up on your gauge. So the blue is going to be on channel A if you're using a 32 or 32X. The Solo has red and blue, that color coding still works the same way. And what you see over here on the right, we're depressurizing the house to negative 50 pascals. And there's not really an exact number that you're looking for. And this isn't going to measure duct leakage for you. It's just going to show you if it's there or not, especially compared to others. So if you're measuring, a series of supplies and you're reading +2, +3, and you get the one that's like +10, then that branch has, much more serious issues than the others. So it can kind of help you narrow down where to focus on when you're trying to get a duct system tighter, especially if that duct system is outside of the building envelope, like we do here in the South. But I know it can kind of happen sporadically around other parts of the country too. So for looking for leaks in ductwork with a pressure pan, this is kind of what's happening as we're depressurizing the house for a duct system outside of the envelope. I mean, that duct system is technically a part of the envelope. When we run a blower door, we're capturing that leakage too in our number. But here, what we're doing is any leakage that comes in from any of the branches, connections, or anything like that, as we put that pressure pan over it, it's really just kind of closing off and kind of completing the envelope around that leak. And that's where we're reading that pressure, that air coming in from the leaks, hitting the box, pressurizing it, and then we can see that it's there. So here's an example here, like we're reading 6.8, which, isn't nothing, but, it's not great. And then versus 1.1. So, okay, like, well, if we can get to 1.1, if we're reading that and we read one that's 6.8, then, yeah, that one's, a lot different than the others. Plus, too, if you have one duct that goes and serves like a box where others split off, then you can kind of see like, okay, if I'm reading 7.2 here and then 7.2 here, then I know I need to focus on that box specifically or the duct that's serving it. But we also use it to read penetrations directly through the envelope too. So you can put it over receptacles, over can lights, really anything you can fit it over that's a penetration through a wall, ceiling, or floor to see if they're leaking or not. When I'm talking with homeowners about can lights, even when they claim that they're airtight, a lot of them aren't. So you can just put that directly over it, seal it to the ceiling with the blower door running, and then show them how leaky it is. If it was perfectly airtight, we wouldn't be reading anything. But since there's air leaking into it, pressurizing that box, we can prove that it's leaky. So yeah, our flow box that you use for measuring bath fans, kitchen exhaust can also be used as a pressure pan when it's all closed up. So if we're running our blower door to negative 50, we take our pressure pan here. That's a leaky wall right there. I mean, 31 out of 50. There's some huge leakage there that's dumping into that wall cavity. So there's definitely something either at the top or the bottom that we want to focus on. The bigger one here for the return, we're only getting about just under 1 here. So not a lot happening with that one. And if you're curious what was going on here, the foundation type changes from this floor to the next room over. The next room over used to be a screen-in porch, and the previous owners enclosed it. So it goes from a crawl space to an elevated slab, and that connection is really leaky. And so air kind of dumps into that wall from the bottom. So we were able to really see that easily from the top of the pressure pan. Thermal imaging. This might be the one that I rely on the most, as long as the weather cooperates. Let's get into this a little bit. I've got an example that I'll show you with the camera that I use now, and just kind of show you what to look for, what not to look for. And since we're getting into it, I'm actually going to let my blower door run a little bit, not too loud. That way we can go ahead and get some like an example to show you of what to look for on air leaks. So we'll come back to that in a minute. We'll let that run, and I'll tell you more about what's going on in the chamber behind me when we get to that point. But for running, for looking at thermal imaging, there's not a whole lot of standards out there to tell you what to do, but I recommend running your blower door to a lower pressure, and even taking just some static images at first, doing some basic scans without your blower door on, just so you can kind of see some before and after, before you run your blower door and after to see what those differences really look like. So that's always a really good practice to do. But the reason why I say to run it low, this standard says, to run it at 20 pascals. That's a pretty good number to run it at. I mean, you can go lower if you wanted to, especially if you have a good delta T between inside and outside. A number that I hear a lot around the industry is like you want at least like 14 degrees between inside and outside. I've been able to see stuff at 10, but I wouldn't go any lower than that. So if you have a pretty temperate day where you get less than 10 degrees difference between inside and outside, plan to use some fog testing as well, or some probing, or some other method to locate the leaks, because thermal is probably not going to work too well for you. So in the spring and the fall, for a lot of us, it can be tough to make this work. But in the summer, the winter, it's awesome. So here's an example. Here's the same leak under different pressures, going from -5 to -50. So -5, 10, 25, 50. And so you can really see how that leak expands. Now, for this particular leak, a window and a door that you would get from Lowe's or Home Depot, that's I'm not too surprised to see that. But if we're looking at passive house or something like that, where every tiny leak counts, it makes a difference. You don't want to over exaggerate that leak and really miss where the source of it is. So there's a big difference between what an air leak looks like at 5 pascals and 50. So starting out low and not just over exaggerating everything at 50 to begin with can be really helpful. But I usually start out around 15 or 20. And then I'll take some pictures later too when I actually run my blower door test at 50. So a lot of times doing your thermal scans before you run your full blower door test is a good order to do things, because you can't really rewind that. You can't make those air leaks go back to where they came from and change those temperatures really fast. So you want to really do this first, then get your number. So a telltale sign of an air leak when the blower door is running is that streaking across the surface that you see. So this is cold air coming into a warm space, and then just kind of streaks across the surface as it blows in. You can see it here too. So like if we took a static image before we ran the blower door and then saw this, yeah, we can see the change that we made by running the blower door. So knee walls, yeah, are common fail points. So corners, well, we often see stuff fail there too. Here we can see some porch beams that are leaking that are tied to the outside. So you can see them streak across the ceiling and down the wall. So that cold air coming in. Ceiling fans. There's a vented attic above that. You can tell, and that's just at -10. That's we're not having to run the fan to -50 to get that photo. So just a little bit of pressure, a lot of times, is all you need. Poorly sealed door there. That's just at -10. We didn't need a lot to see that. Here we've got a double whammy. We got missing insulation and air leaks. So if we took this photo with a thermal camera without the blower door, all we would see was the missing insulation. But since we have the blower door running too, we can see both at the same time. And that's just at -15 pascals. You can see air leaking into insulation before it's covered, before the drywall gets put on. Plumbing stack not sealed, so hot attic air coming into the wall there. Same thing, but in the winter. So we see that cold, dark air dumping in there. The supply boot not being sealed to the ceiling. We can see what the effects are on that. So that hot attic air being able to come in around that boot. Cold air coming in around receptacles. A lot of us have seen that. Windows. That one wasn't properly flashed or sealed around the rough opening. Uninsulated attic hatches, as well as they're not really sealed around the edge here. On this one, you can kind of see air leakage and missing insulation at the same time. And you can see if windows are starting to fail too, if the gas is starting to leave. So it's happened on those top two. This bottom right one's still okay, but this one on the bottom left's on its way out. So you can see if windows are starting to fail or not. But just because you see a color difference doesn't mean it's always air. This is one reason why I like to do static images before I even turn the fan on. This is moisture. Excuse me. This is moisture, water. This wall got wet. And you can tell because it's not insulation, because it doesn't really follow the stud base. You can just kind of see where it got wet, and then it kind of slowly wicked up the drywall there. Same here. This isn't an air leak. This is a water leak in a roof. This is a roof leak. So if those kinds of issues were going on, you would see that before you even turn the fan on. So you would know it's not really an air leak if it's that dramatic. I mean, sometimes you'll see some air leaks. You'll definitely see thermal bridging without a blower door running. So that's why it's really important to take those static images first. You might find an issue that's just not related to air leakage at all that you would interpret as air leakage if not. So it's important to understand, like, oh, I see a dark or a bright, white color. It's an air leak. That's not always what it means. It could be something else too. So this room flooded. So we can see this one got wet. Yep, that's not an air leak. It's not streaking. It's just kind of stagnant. Yeah, we'll go ahead and play this. So if I'm inside of the building, I want to depressurize it so I can see that air move in through the leaks. So this is another spot where we have knee walls. We can see some kind of cold air. This is just when the fan's turning on. Not a lot moving yet. Now we're at about -10 pascals. And we can see that kind of streak across the surface with our thermal camera. So that's air coming in underneath the bottom plate that's connected to an attic on the other side. Living room, we can see just a kind of a combo of air leaks and some insulation that's either falling out or just wasn't installed well. So kind of got air leaks and thermal bridging going on at the same time. This is that spot that I was talking about before, where the foundation changes. So we can see a lot of cold air coming in from the crawl space there. And with a lot of cameras, you can do different stuff. So you can do like a thermal overlay, straight thermal. So that way you can kind of get a clearer image. And then you can do like a picture in picture if you want to focus on a specific spot. So that's with the Hike micro camera, but pretty much any camera will allow you to do that. And I like using wireless cameras and mirroring it onto my device. So that way I can screen record video with it. So that's how I take a lot of these thermal videos that I take. If a client's not there, but I want to show them this scan, that's just a good, easy way to do it. Just tether it to your iPad or your phone, screen record. That way you have a nice video of what happened. So I'm going to back out here and show you this. Okay, so my zoom settings are kind of in the way. Here we go. All right, well, I'll just leave it. So the camera I've been using lately is the Testo H60i. I really like it. I'll show you why in just a minute. And so this was just without thermal. So we can kind of see we've got an air leak. It's blowing that smoke away. But if I switch it over to thermal, there's a few things going on here. So if I take it back out, I just wanted you to see, you can't really see it as well. Let's put it back on visual here. So I've got a couple of pieces of insulation in here and here. This is not insulated. That's just plexiglass. Let's put it back on thermal. I left a crack here, so you can kind of see that air escaping out. So we can definitely see some streaks going across where that air is leaking. I'm at about 26 pascals. If I would have choked my fan down to a lower range, probably would have worked a little better. But you can kind of see in the center of that insulation panel, it's not really being affected too much, but it's heated up in there. That space heater has been running for a while. So we've got a mixture of air leaks and thermal bridging that's happening. It hasn't really affected the center of that insulation panel yet, but it has heated up quite a bit. But now that I've been running the fan for a little while, I can actually turn it off and it will probably still show up. There we go. Yeah, you can still see those streaks across the surface there where it's blowing out. So that's your telltale sign of what you want to look for. You want to see those streaks. That's an air leak. And like I showed you before, you don't need You don't need a lot of pressure to make that happen. Just like 10 pascals will do it, especially if your delta T is good. So it's good to keep track of what your indoor temperature is, what your outdoor temperature is, and what your pressure is when you're running your blower door. Those are all good things to record if you're going to report an image back to a client. Let's see here. Let's get back to the presentation. Um, let's get back into presenter mode. There we go. So this is the camera that I'm using. I can actually go ahead and grab it. So this is what it looks like. It doesn't have a screen, but it has this little clip that you can clip a phone into, so you can give it a screen. But in a lot of cases, I like to leave it detached because a couple weeks ago, I went and looked at an attic that had a spray foam job done, but it doesn't have an attic access. That attic is really low. It's kind of built into like a half story. So I really couldn't get in there and do a good evaluation, but I could just reach my arm up in there and then have my phone in the other hand and just kind of look around, pan around, and get a good idea of what was going on. So what I was able to see were some failures kind of all over the place. There's a gable end I was able to go see. So I only had like about 10 inches from that ridge beam down to the ceiling below. So there's no way I was getting up there. But since I could kind of get my arm through a panel, I could really look around and see some different things. And what we determined is that they missed a bunch of stuff everywhere. Unfortunately, if they're going to go back and fix this with spray foam, they're going to have to drop the ceiling, the whole thing, to get to it, which really sucks. But this is a good way to find some bad spray foam jobs because you can usually get your arm into some pretty tight spots and really get some good views. But if the camera has a screen, I mean, you have to be there to look at it. But with this, you can really just use it like a wand to get in and get some good shots where maybe you wouldn't otherwise. So that's one reason why I really like this camera. And for it to be so small and inexpensive too, it's got a pretty decent resolution on it. So this is the one that I've been using lately, just for looking at problems in houses and stuff like that. It's really good for that. So I like the fact that either it can have a screen or not. It's up to you. But it was really helpful for this particular comfort consult. So I'll leave with probably one of the most common questions that we get is like, when is a house too tight? And how do we go about thinking about that? And what are the things that matter that go into it? BPI, they kind of say like, okay, well, when a house gets too tight, right, you got to add some mechanical ventilation. Okay, well, when do we need to do that? The Florida Energy Code requires it when it gets below 3 air changes per hour. BPI recommends when it starts to get below 5 air changes per hour at 50. My opinion is that really every house should have mechanical ventilation. It's really nice to control where that air comes from and filter it, and try to control the humidity with it too. If it's an ERV or if you're using a ventilating dehumidifier, but yeah, I mean, really, the tighter it gets, the more we really have to start thinking about when that mechanical ventilation comes into play. But I mean, the answer is like, you can't get a house too tight. You can get it as tight as you want, but mechanical ventilation is going to become important the tighter that you get. And the reason that we ventilate is to keep our air clean. We don't want it to get stale and stagnant and collect a whole bunch of pollutants that we just keep breathing in. We want to be able to cycle that out and bring in filtered fresh air in to replace it. So a way to kind of keep track of that is to measure it. There's some really good indoor air quality sensors out there now. CO2 is a good indicator of when we need ventilation. When that's getting high, if it's getting, close to or over 1,000 parts per million, yeah, we want to ventilate that space a little bit better. I really like the Haven indoor air quality monitor because it's measuring the whole house. You install that into a return duct. And it also has a controller that can be wired to open your ventilation whenever your indoor air quality starts to decline. So if your VOCs start to get high, they also have room monitors that'll read CO2 that'll communicate with this. So it really just responds to when you need it instead of just running it randomly when maybe you don't. And plus, it'll also run your air handler to filter the air if particulate matter gets too high. So it's really just it's kind of a demand response approach to ventilation instead of just putting it on a timer. So that's a nice way to do it. But really, it's like, okay, well, when do I need to ventilate? When do I need to think about ventilation? We'll just measure and see what you have first, and see what happens. But again, in my opinion, I think we need to really think about mechanical ventilation for every building, but especially as we get tight, it becomes more important. And again, the answer to that question is how tight is too tight? That there's no number for that. You can get it as tight as you possibly can. The more the merrier. And then put in a plan for something like this to make sure that your air stays clean and measure it. So I wanted to end with that because that's just one of the most common questions that I answer every single day, especially for home builders that are getting into this, that are kind of concerned about changing the way that they build to get tighter. Well, I don't want to avoid one problem and get into a new one. Well, you're not, as long as you plan to ventilate as you get tighter, because they go hand in hand. Uh, that wraps this up. We left a few minutes here. Again, if you haven't seen our YouTube channel, this will be recorded and put there so you can share it with somebody on your team or reference it later. There's all kinds of resources on there too, from other recorded webinars to our video series, Technical Tuesdays, that dives into the weeds on all kinds of things. Our podcast, the Flow Lab, that we started earlier this year, is myself and Ben Walker, one of our co-CEOs. You can find those there. So you are listening to it on Spotify, Amazon, or Apple. We always have a guest from the industry to kind of talk about what's going on or some of the history of where we came from. But there's my information as well as our support team. So as you are getting into this and have questions, you can contact me. You can also contact our support team. There you'll find Noah, Tim, and Lee, who have tons of experience from addressing these kinds of issues. So really appreciate all of you joining today. And Noah, we can go ahead and take some more questions if we have anybody hanging out here.
Yeah, so again, just email us at support@Retrotec if I didn't touch on your question in the chat, or if we don't hear, I would be happy to talk more. So we've got, with the pressure pan and testing duct work, do we need to seal off all of the other ducts? And then can we talk about that on hardwood versus carpeted floor?
Yeah, no, you don't need to seal off the other ducts. You can just leave it as is. I mean, those, as you're running your blower door, I mean, that air is going to leak through the leaky ones and really not through the non-leaky ones. Don't worry about precision here. I mean, you're really just looking for anomalies. Your leaky branches are going to read higher than those that aren't leaking as much. If you have hardwood floors, that's great. You'll make a good seal against it. If you have carpet, just push down on it, put some pressure on it to make sure that it's not leaking around the edge. But you can use it with carpet. I've definitely done that before and been able to see what I need to see.
Yeah, and then for thermal imaging, a radiant barrier will also cause some thermal imaging anomalies. So that's something to keep in mind if you're doing tests in houses with thermal
Yep,
barriers. That was one of the questions or
good
comments. And
point.
then what model FLIR camera were you using? So you used three different brands in that presentation.
Yeah,
So
yeah. The FLIR, I don't remember. That was so long ago. If you want one that's like has a much higher resolution that you're going to spend a lot more money on, the Hike Micro M30 is a really good, is a really nice one that you can really focus in and get some good photos on. But what I've been using is just this the Testo 860i. That's kind of what I've been using here lately, and it's awesome. I think what the plan now is too is also to get the app into the DM32X so you can actually use your manometer screen as the camera screen, and honestly, even fits on there too. So that way you can kind of turn your gauge into a thermal camera. So we're going to get the app put into that so you can kind of download that as an option. The Hike Micro app is already in there. So if you're using like the Pocket 2 or the M30 or something like that, as long as it's wireless, you can pair it to it and use that and save some photos to your gauge and then add them into your R Cloud report too. So yeah, you can also do that. But yeah, we're gonna add the Testo one in. They like the idea. They play nice with us. So yeah, I can't wait for that.
yeah, so there's small typo. We are support at Retrotec, not
Oh,
Retortec.
sorry about
But I think
that.
hopefully most people caught that.
Yeah.
Yeah, there's a lot of thank yous, and the new blower door power drive is always external. Is that why it's always lighter? It's still lighter than the other high-powered fan that was also an external power drive. So it's lighter than the previous version that also had the external power. But yeah, it is
Yeah.
somewhat I guess some of the weight was shaved off if you're comparing it to like a 5,000 that had that
Oh,
all
there's
in
a
the,
huge difference in weight between the
yeah.
7,000 and the 5,000. It's like 30% lighter. So like 21 pounds as opposed to like 36. So yeah.
Yep. So, can we apply for BPI CEUs? That came in twice now.
Oh yeah. We did not do that for this webinar, unfortunately. We honestly haven't done it for a while. We just, I think the past few webinars, like a while back, like nobody put their number in. So it just didn't seem like people were looking for it. But if that's something people want moving forward, yeah, we can work with them to get those classes registered.
All right. Yeah. Another one that's support related. DM32 5Hs can still be upgraded. We will upgrade to a 10A sensor and calibrate the DM32 still. And for the question about adding a spot for a permit number, is that for our cloud or Fantastic? These are all great questions, but I think I can answer them if you email me at support at Retrotec.
Not
Um,
Retrotec.
yeah, Retrotec. And they said we would just need a proof of attendance email or cert of completion to get the BPI CEUs. Do
I'm
we
sure we
know
can
of a
put something together for that.
Yeah. Do we know of a control manufacturer that can switch an HRV on and off via comparing outdoor versus indoor enthalpy differences? I think Haven would probably be,
Even
is that,
might. I think they
I don't
have
know.
some. I think they can reach out to them. Kevin Hart, Kevin the as he calls it, Kevin the Canadian, not Kevin the comedian. He heads up Haven. So yeah, just shoot them a message. You can go to their website and get the email. Yeah, ask them. Yeah, they're pretty quick to reply. They'd be happy to help you.
Yep. According to Kirsten, who used to work at BPI, they can self-attest for CEUs. The podcast is the Flow Lab. You can find it
Yes.
on YouTube, on our YouTube page, or any of the platforms that you normally stream podcasts on.
Yeah, it's called the Flow Lab. We launched it earlier this year. Our first guest was Harold Orr. He invented the blower door back in the late 60s. It was his thesis work for his graduate degree. So it was invented in Saskatchewan, in Canada. And the first blower door fan was a fan taken out of a plane to pressurize cabin pressure, to pressurize the cabin that was used in World War II. And he picked that one out of an auto supply parts store. And because he was able to make it variable speed pretty easily and just use that with a sheet of plywood and a magnehelic manometer. And that was the first blower door. So he tells that story on our first episode. It was really cool. Harold's into his mid 90s now and still sharp and loves to tell that story. So yeah, check it out.
So last two, and then I'll call it. If we can talk about ERVs, how does it interfere with the blower door test if it's open outside, not sealed? Most standards, if it's a continuous ventilation method, will allow you to seal things for tests. So hopefully it's in a location where it can be sealed, but that's my recommendation personally. I don't know about you, Sam.
Yeah, I mean, ResNet 380 will let you tape it off if it runs continuously. A lot of them don't. They might run intermittently. So that's important to know. Like, how is it going to be used? Otherwise, if it's used intermittently, you have to leave it as is. And that can depend on manufacturer and installation. So some manufacturers have dampers built closed until it comes on. So I mean that can really vary. I mean that one answer is not really going to apply to all ERVs and all installations.
Yeah. Last one was if we will do a webinar more aligned to the fire protection industry. So
We've been
that's,
getting requests for that. So
yeah,
guess
stay
we're due
tuned.
one. Yeah.
And I
Cool.
think,
So yeah, if that's it. Again, if you have more questions, yeah, please reach out to you can get Noah at support@retrotec.com. You're welcome to email me as well. Also, always happy to help. So thanks for logging on and joining us. You're welcome to shoot us any feedback too. We'd love to hear from you. Other topics that you'd like to share or for us to share that would be helpful for you. So we want you guys to be successful. We want you guys to use our tools correctly, and we want them to do the best job that they can for you. So let us know. And thanks again. Next week's Thanksgiving. So hope everybody here in the States that celebrates has a good, safe week, especially if you're traveling. And we will see you next time. Thanks.